This is an exponentials and logarithms question. Give it a go first, see how far you get, and if you get stuck on anything, then just look through the video to see my working for each part. So for part A, we're trying to sketch y is equal to 4 to the power of x, and state any points of intersection with the coordinate axes. So the curve that we have here is of the form y is equal to a to the power of x, where a is a number that is bigger than 1. And whenever we have a curve of this form, it always looks the same kind of way, which is like this, where this coordinate here is 0, 1, and towards the right you see the curve getting steeper and steeper and steeper, and towards the left it gets shallower. The curve, the y-coordinate of the curve approaches 0, or in other words, we have an asymptote, which is the x-axis, and that will be y is equal to 0. So why is this the case? Let's start with the intersection. That's probably the most straightforward one. If we put in x is equal to 0 into our curve, y is equal to 4 to the power of x, well, anything to the power of 0 is just 1, and that's why we get this coordinate. So let's look at the right-hand side of the graph now. This should also be straightforward. If we have y is equal to 4 to the power of x, as we let x approach positive infinity, the power for this gets bigger and bigger, and as the power gets bigger, well then y will just approach positive infinity. As x approaches negative infinity, well, this is probably the best way to think about this is to consider an example. So if we have y is equal to, let's say, 4 to the power of minus 10. So this is the same thing because of the negative power as 1 over 4 to the power of 10. So as this minus 10 approaches minus infinity, this 10 here will approach positive infinity, or in other words, the denominator will just get bigger and bigger as x approaches minus infinity. And if your denominator gets bigger and bigger, well then the entire fraction will just approach 0. So y will approach 0. It will never actually reach it, and that's why we have an asymptote of y is equal to 0 for this graph. So for part B, we are solving 4 to the power of x is equal to 100. So the most straightforward way to solve this question is to take log to the base 4 of both sides. So the reason that works, the rule is, if you were to have log to the base a of a to the power of x, this is just the same thing as x. And the reason for that is because these two functions, log of a of x, log to the base a of x, and a to the power of x are inverse functions of one another. They do the opposite thing to each other. So if you do a to the power of x, whatever that does to x, log to the base a then does the reverse and effectively cancels out with the a. And so we're just left with x. Following that logic, we can also say that if we were to have a to the power of log to the base a of x, well, this will also just be equal to x, as the a to the power of and the log to the base of just cancel out. So then the left-hand side of this equation, log to the base 4 of 4 to the power of x, now we know becomes x, and the right-hand side, we can just type this into our calculator, and we end up with 3.32. So that's one way of doing it. Another way that we can do this is to take log to the base 10 of both sides. So log to the base 10 of x, we can just write as log x. That makes things a bit simpler. So the left-hand side of this equation becomes log of 4x, and remember that means log to the base 10 of 4 to the power of x. And the right-hand side becomes log to the base 10 of 100. The left-hand side now becomes x log 4. So what we've used there is the power law, which is if you were to have, let's say, log to the base of a of b to the power of x, this is just the same thing as x log to the base a of b. So the power comes in front and now the two things are multiplied by one another. And so this equation, the right-hand side, still remains log 100. And because these two things are now multiplied, we can divide both sides by log 4, and this becomes now log 100 all over log 4. Type this in your calculator, you get the same thing, 3.32. Now just bear in mind that this isn't the same thing as log of 100 divided by 4. If you were to type this in, you wouldn't get the right answer. You'd have to do log of 100 on the numerator and then log of 4 on the denominator to get the correct answer.